8th graders, and welcome back to another exciting lesson. Go ahead and please take out your math notebooks and turn to a clean sheet. Name today's date. Let's go ahead and write down our objective today. Our objective is I can distinguish between irrational and rational numbers. Last time we talked about looking at square roots. Now, square roots can give us one of two numbers. For example, if I have 25, it can give me a whole number. The whole number with square root of 25 will give me 5. But if I have, let's say, the square root of 26, for example, the square root of 26, looking at my calculator here, will give me the number 5.099019513, and I can keep going on and on forever. This kind of number is never ending, meaning there is no end point to this number. With regard to that, these two types of numbers, or these two types of square roots, give us what's known as rational or irrational numbers. A rational number is a number that has an end to it. Notice that my 5 has an end to it. However, in this number here, this is what's known as irrational. Irrational numbers are numbers that are never ending. So if we were to, let's say, look at the following numbers, are these numbers irrational or rational? We have the number 0.07. Is that number irrational or rational? Correct. The number is rational. Why? Because it has an endpoint. Now, looking at the number 0.3 repeating, now remember, 8th graders, when a number has a line on the top, it means that it goes on forever. This type of number is known as irrational because it is never ending. That's pretty easy. But as I normally say to all my classes, let's kick it up a notch, shall we? Let's say off the top of our head, square root of 4. Is the square root of 4 rational or irrational? That's correct. It is rational. Reason being because the square root of 4 gives us an answer of 2, or the whole number of 2. Correct. But what about the square root of 2? Correct. It is irrational. Reason being because if you plug this in your calculator, the square root of 2 will give you a number that goes on forever. So when looking at these types of numbers, and I'm going to give you a little bit of a tip here, 8th graders. When looking at numbers or square roots and classifying them as either irrational or rational, you often want to look at, you want to make sure you memorize this and copy this into your notes. You often want to look at your perfect squares. Your perfect squares are numbers that when multiplied by the same number, you end up with a number. So like we've talked about, and probably you've talked about in previous grades, 4 times 4 is 16, so let's start at the beginning. So 1 times 1, well, that gives me 1. 2 times 2 will give me 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. And 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. I could keep going on, but these are some of the basic perfect squares you can see generally when looking at any type of number. So if you see a square root on your homework that has this type of perfect square, it's going to be a rational number because you get a whole number with an endpoint. All right, let's go ahead and look at your homework. Will be posted on Google Classroom. Again, it is 8 to 6 questions. If you do have any questions or concerns, please feel free to give me an email. I'll be happy to help you out as best I can. All right, go ahead and copy down your exit slip for me now, please. The first one being the square root of 200. The second one being 0.0057. And lastly, square root of 121 over 5. I'll go ahead and give you a second to pause this video to answer those questions yourself before I go over these with you. All right, let's go ahead and answer them, shall we? The square root of 200 is obviously an irrational number. Reason being because it is not a perfect square, and if I were to plug this in your calculator, I would get a decimal that goes on forever. Number 2, this number is rational. Reason being because it has an endpoint. It doesn't continue on past 7. And finally, our last question. I couldn't stump you, could I? The answer is rational. Now you're probably thinking to yourself, wait a minute, Mr. Campbell. There is a fraction and there's a square root. What does that mean? Well, 11 over 5, because 121 is a perfect square. A perfect square gives me 11, and 11 over 5 would give me 2.2, which is a non-repeating decimal. Thank you so much for joining me on this lesson today. Tune in next time when we delve into Pythagorean theorem and look at how square roots can sometimes play into finding the area and perimeter of geometric figures. Stay tuned.